Hello and welcome to the demo of my first web app, which consists of views located on these first 4 links. In this demo, I will give you a brief overview of the web app as a whole, and then provide a brief demonstration of the use of the first link here, One Interactive Demand Request Rate Heat Map. My first web app serves to visualize incoming realized demand requests made by individuals and departure units over time across the entire state. As a reminder, a demand request is simply a characterization of the arrival of the first arriving individual for a group of individuals, or departure unit, which departs in a single A taxi. This is useful because, in reality, such an arrival time represents the time at which we realize the physical demand for one additional A taxi at a given pixel. So all demand request data on this page is generated from the OR467 dataset in the infinite fleet case, performing rideshare analysis on the usual parameters that common destination equal to 3, departure delay equal to 300 seconds, and max acuity equal to 20%, accumulating these demand requests over 10-minute intervals. In the infinite fleet case, demand requests occur exactly departure delay seconds before the departure times of all departure units, and demand requests occur within departure delay seconds before the departure times of all individuals. While the difference in time for a demand request and a physical vehicle departure in the infinite fleet case is simply equal to the departure delay, or here 300 seconds, there are 2 reasons that I chose to visualize demand requests instead of dispatches. First, demand requests are relevant in forecasting demand for any anti-vehicle repositioning policy in the finite fleet case. Second, the primary goal of this thesis is to make steps towards optimal anti-vehicle repositioning and fleet sizing policies. And the differences in loaded vehicle dispatch times on the same sample path between the infinite fleet case and a finite fleet case may be significant, while the arrivals of these individuals on the same sample path are identical, and their corresponding demand requests made by the departure units associated with those individuals will be similar. As I mentioned before, this web application contains 4 pages, and a link to each page is located right here. Now, as of the publication of this thesis, each of these pages loads and parses a large JSON file and 2 large CSV files that allow the user interface to be quick and agile at the expense of a longer page loading time. As you can see in the activity monitor, this one page may require over 1 gigabyte of memory on your computer. So now this One Interactive Heat Map page contains a slider bar with 2 endpoints near the top of the page. Beneath the slider bar is a zoomable map of New Jersey. Beneath the Google Maps API heat map layer, in which different heat levels at each pixel correspond to different numbers of demand requests. By sliding the left endpoint corresponding to different 10-minute intervals, which are also located here on the current display, the demand requests displayed on the map change accordingly. Let's take a closer look. As we zoom in, we notice that as we mouse over different pixels, we see in the bottom right, I'll move my mouse for a second here, the number of dispatches or demand requests made in that 10-minute interval. And zoom closer in and see exactly how many dispatches are made at each pixel. Zoom back out a little bit. Now we can see that the Google Maps heat map layer API is not perfect. As we zoom out, we see that the blend of colors on the screen changes significantly. I use my own coloring method in one of the other web apps, Interactive Pixel Color Map, to fix this issue. Let's go ahead and try out the animation. As I mentioned before, you can use the slider to change the current 10-minute interval, and you can use the end slider to change the endpoint of the animation. Let's make it simple and go for an animation over the span of 1 hour. Instead of sliding the bars, you can also select time intervals explicitly. Let's make things incredibly simple. Change it to 8 a.m. to 9 a.m. We can also change the minimum demand and maximum demand requests displayed on the map at any given time. I can change the delay of how many seconds I want to display each different image throughout the animation. When I'm ready to go, upon clicking animate, we'll see that the slider bar advances every 2 seconds and the image changes accordingly. Upon the end of the animation, you see that the current position and end position are equivalent. You can also perform these animations and views using individuals, arrivals, instead of departure units, demand requests. Thank you.